Yeah. Hello, everybody. Um, as I told you, I would use mostly audio files in order to teach remotely. But I've discovered, as I've worked through the material, that some stuff is really visual, and we have to use video. And so I've brought in a beautiful production assistant today to help me film this particular lecture that requires visual demonstrations of various kinds. Okay? So this lecture is on maps and map projections, right? And as you'll see, in archaeology, we use a lot of maps. Archaeology, by its very nature, is very spatial, and therefore we use many different kinds of maps, and we also make our own maps, and I'm going to talk a little bit about how we do that, and I'm going to show you some techniques that we use to do that. And we're supposed to have a quiz on that as well. We're supposed to have field exercises, which I'm pretty sure we're not going to have, but I'll do my best to substitute for them by using some combination of video and audio. So open up your PowerPoint presentation on map projections. It's called mapprojections.pptx, right? And the first slide, as you can see, just says map projections, right? And so let's go to the second one, okay? And so, map projections are the mathematical systems or functions that we use to flatten out the globe so that it can be represented on a flat two-dimensional sheet of paper, right? Now, you all know, I hope, I mean, maybe there are some round world deniers in the class, but I hope that most of you realize that the Earth is round, right? And I have here a very cute little globe, right? And as you can see, right? As you can see, you know, the land masses and countries and other features of the Earth are printed on this roughly, what, spherical little, I think it's a rubber ball, you know. Well, the Earth, of course, is not a perfect sphere. It's an oblate spheroid, right? Meaning that it bulges out along the line of the equator, in part or perhaps completely because of the angular momentum of the rotation of the Earth, right? So this is essentially an approximation of the form of the Earth, and what we ultimately need to do is to take part or all of the surface of the Earth and flatten it out into a two-dimensional representation so that, you know, we can print it on paper and look at it and consult it, right? So a map is a symbolic representation, typically in two dimensions, of some part of the surface of the Earth. And it's important to remember that it is a symbolic representation, right? It's not a copy or an attempt to copy or model. It's a symbolic representation in which symbols are used to represent different kinds of features, right? And we will talk about how you interpret those symbols, okay? Now, in the process of doing our work as field scientists, we use a number of different kinds of coordinate systems and projections. And as you can see from the slide, the first one I want to talk about is latitude and longitude, right? Now, this little globe actually has, when I turn it right side up, it's probably impossible for you to see, but it does have lines of latitude and longitude drawn on it, right? And the question is, well, you need to know how latitude and longitude works. Because when you use, for example, a GPS, don't worry about it. When you use a GPS, you know, it will probably give you your location by default in latitude and longitude. And you need to know how to interpret that and what it means and how to convert it to other systems, right? So, also, as I've mentioned before, we use geographic information systems a great deal in archaeology, right? And the native format for recording location, both for the GPS and for GIS, is latitude and longitude, specifically in a format called decimal degrees. And we will talk about what that means and how to convert degrees, minutes, and seconds to decimal degrees. We'll talk about that in a minute, right? But the first thing we need to talk about is latitude and longitude and what it really is.